We often assume that places which feel unreal belong to movies, simulations, or digital worlds, creations shaped by computers, not by Earth itself, but scattered across this planet are locations that defy that assumption. They are real, they are physical, and they exist far beyond the reach of illusion. These are not accidents, and they are not miracles. They are the result of three forces working in silence: human ingenuity, natural cycles, and deep geological time. For thousands, sometimes millions of years, water moved, rock fractured, heat rose, wind erased. And in rare moments, humanity intervened carefully, boldly, or desperately. Some of these places were shaped almost entirely by nature. Landscapes carved drop by drop, grain by grain, molecule by molecule. Others exist because humans refuse to accept the limits of terrain, climate, or isolation. Highways stacked in mountains. Villages submerged beneath water. Sacred spaces carved into stone. This journey is not about the most beautiful places on Earth. It is not about popularity or spectacle. It is about locations that interrupt certainty, places that make even experienced explorers pause and reconsider what they believe is possible. Here, deserts resemble alien planets. Lakes burn with color and chemistry. Caves open into spaces so vast they erase all sense of scale. Ecosystems appear for only a few weeks each year, then vanish again into silence. These are Earth's impossible wonders, not because they break the laws of nature, but because they reveal how powerful those laws truly are. As we move through these landscapes, one truth becomes clear. Reality does not need imagination to be astonishing. It already is. The question is not how these places exist. The question is, how much of our planet remains unseen simply because we have not yet learned how to look. High in the mountains of northern China, where steep slopes and fractured rock leave little room for error, the Tianjin interchange rises as one of the most complex transportation structures ever built. From above, it appears almost unreal highways, twisting, looping, and stacking into a dense three-dimensional maze that seems to defy gravity and intuition. This interchange was constructed in a region where nearly 90% of the terrain is rugged karst landscape. Deep valleys, unstable rock formations, and sharp elevation changes made traditional road design impossible. There was no flat ground to expand across, no simple route to follow. Instead of fighting the terrain, engineers chose to work vertically, layering movement into the air. Multiple levels of ramps coil around one another, some rising more than 100 meters above the valley floor. Reinforced concrete pillars anchor the structure directly into bedrock, while seismic-resistant joints allow the interchange to flex during earthquakes. Every curve, incline, and merge was calculated to manage speed, load, and vibration in an environment where failure could be catastrophic. Construction was slow and unforgiving. Crews battled dense fog that erased visibility without warning, heavy monsoon rains that destabilized slopes, and cliffs so steep that equipment had to be suspended by cables. Each segment was built with millimeter precision, often poured and assembled under conditions that would halt most conventional projects. From ground level, the interchange feels overwhelming. Ramps cross overhead in every direction, casting layered shadows that shift throughout the day. Vehicles appear and disappear above and below, moving through space in ways that feel closer to choreography than traffic. Yet, despite its visual complexity, the system functions with remarkable efficiency, guiding thousands of vehicles through the mountains every day. What makes the Tianjin interchange extraordinary is not its size alone, but its geometry. The structure transforms horizontal distance into vertical movement, compressing space in a landscape where expansion was impossible. Mathematics becomes visible here, flow replaces straight lines, motion is stacked rather than spread. The interchange also represents a broader shift in infrastructure design. As populations grow and terrain constraints tighten, transportation can no longer rely on two-dimensional solutions. Roads must adapt to elevation, geology, and density simultaneously. Tianjin demonstrates how infrastructure can evolve when land itself refuses cooperation. Importantly, the structure does not erase the mountains beneath it. Instead, it threads through them. The rock remains, the valleys remain. The interchange becomes a temporary layer, a human system placed delicately within a hostile environment, rather than imposed upon it. For drivers passing through, the experience is brief. Minutes of elevation, curves, and transitions. But from above, the full scale becomes clear. This is not just a junction of roads. It is a man-made landscape shaped by calculation, risk, and persistence. The Tianjin Interchange stands as proof that modern engineering no longer moves only across the Earth. It moves within it, around it, and above it. In a place where geography once dictated limitation, human design found a way to stack possibility layer by layer into the sky. High in the Himalayan foothills of central Nepal, there exists a tradition so dangerous and precise that it feels almost unreal. The Mad Honey Cliffs rise hundreds of feet above deep valleys, their vertical rock faces battered by wind, cold, and silence. To most people, these cliffs look unreachable. To the Gurung communities who live here, they are a source of life, risk, and ancient knowledge. Clinging to these sheer walls are the massive hives of Apis laboriosa, the largest honeybee species on Earth. Each hive can span more than a meter across, suspended on bare rock with no visible support. The bees thrive in this extreme environment, feeding on rhododendron flowers that bloom high in the mountains. Twice a year, during narrow seasonal windows, honey hunters climb these cliffs to harvest what is known as mad honey. They use hand-woven bamboo ladders, tied together and lowered from the top of the cliff. There are no harnesses, no modern safety systems, only rope, balance, and trust passed down through generations. As the ladders sway in icy winds, hunters descend toward the hives. Smoke from burning leaves is used to calm the bees, though it offers limited protection. Thousands of bees swarm the air, stinging exposed skin as honey drips down the cliff face below. The honey itself is unlike any other. Because it is made from rhododendron nectar, it contains natural neurotoxins known as gray anotoxins. In small doses, the honey can cause dizziness, altered perception, and vivid hallucinations. In larger amounts, it can slow heart rate, lower blood pressure, and become fatal. For centuries, this honey has been valued for its medicinal and and cultural significance. Local healers use it carefully, understanding its power and limits. Scientists now study it for potential pharmaceutical applications. Anthropologists study the ritual itself, fascinated by the precision and restraint required to survive it. The cliffs are often surrounded by waterfalls, fed by melting snow. Cold air rushes upward from the valleys. One misstep means a fall with no second chance. Every movement is deliberate. Every harvest is a negotiation with gravity. What makes the Mad Honey Cliffs extraordinary is not just the danger, but the balance. This is not exploitation of nature. It is coexistence. The hunters take only a portion of each hive, leaving enough for the bees to survive and return. Here, human presence is temporary. The cliffs remain. The bees remain. The ritual continues, unchanged by time or technology. In a world increasingly shaped by machines and automation, the Mad Honey Cliffs stand apart. They remind us that some of humanity's most remarkable achievements are not built with steel or concrete. They are built with memory, patience, and respect for forces far greater than ourselves. This is not a spectacle designed for observers. It is a quiet, dangerous conversation between humans and the extreme edge of nature. One that has lasted for centuries. Hidden beneath the limestone plateau of eastern Oman lies a space so vast that it challenges the human sense of scale. Majlis al-Jinn Cave is one of the largest underground chambers ever discovered on Earth. From the surface, there is almost no sign of what exists below. Only a few narrow openings break the rock, hinting at the void beneath. The cave was formed over millions of years as slightly acidic water slowly dissolved thick layers of limestone. Drop by drop, the rock weakened. Cracks widened. Eventually, gravity took over. What remains is a chamber nearly 340 meters long and more than 200 meters wide, with a vertical drop of over 120 meters from the surface. Standing at the edge of one of the cave's openings feels unreal. The darkness below absorbs light completely. There are no visible walls, no sense of depth, only silence and the awareness that the ground disappears instantly beneath your feet. Natural skylights pierce the cave's ceiling, allowing thin shafts of sunlight to reach the interior. These beams move slowly throughout the day, tracing patterns across the stone floor far below. Dust drifts through the light, emphasizing the emptiness of the space. Sound behaves strangely here. A single voice echoes endlessly, stretched and distorted by distance. Majlis al-Jinn is not easily accessed. There are no walkways, no gradual descents. The only way inside is vertical. Extreme explorers descend through narrow openings, using ropes, dropping into darkness for several seconds before reaching the cavern floor. For base jumpers, the cave represents one of the most dangerous jumps on the planet. They leap through a small opening, free-falling in total darkness. There is no visual reference, no horizon, only rushing air and instinct. Parachutes must deploy with perfect timing, just meters above solid rock. Those who survive describe a unique sensation, not fear alone, but disorientation. The absence of scale erases perspective. Up and down lose meaning. The cave feels less like a place and more like a void. Despite its danger, Majlis al-Jinn remains largely untouched. There are no permanent structures, no lighting systems, no crowds. The cave exists on its own terms, shaped entirely by geological time. What makes Majlis al-Jinn extraordinary is not just its size, but its honesty. There is no illusion here, no color, no decoration, only raw space carved by water and gravity. It reminds us that Earth's most extreme environments do not always rise above the surface. Some descend deep into it, and in those depths, the planet reveals a scale that dwarfs human ambition. Majlis al-Jinn is not a cave meant to be conquered. It is a place that demands humility, a reminder that long before humans measured the world, the Earth was already shaping spaces far beyond our comfort or control. Here, exploration does not mean progress. It means restraint and the understanding that some wonders exist, not to be entered easily, but simply to be acknowledged quietly and with respect. Beneath the rolling hills of Kentucky lies a world that quietly rewrites our understanding of scale. Mammoth Cave is the longest cave system ever discovered on Earth. More than 400 miles of passages have already been mapped, and scientists believe that this is still only a portion of what exists below. From the surface, nothing appears unusual. Forests stretch calmly across the landscape, rivers flow without drama. Yet beneath this familiar terrain, limestone has been dissolving for millions of years, hollowed out by slightly acidic groundwater moving slowly through hidden fractures. The result is not a single cavern, but an underground network of astonishing complexity. Vast chambers open suddenly from narrow tunnels. Ceilings rise like cathedral vaults. Passages twist, branch, and disappear into darkness, forming a subterranean maze shaped entirely by time. Inside Mammoth Cave, geology becomes readable. Smooth flowstone records ancient water movement. Gypsum crystals bloom on walls like frozen feathers. Layers of rock preserve evidence of climate shifts stretching back tens of thousands of years. This is not just a cave, it is an archive. Human history runs just as deep. Archaeological evidence shows Native Americans explored these passages more than 4,000 years ago. Torch marks still cling to the walls. Footprints hardened into clay remain where light once flickered and vanished. Later generations mined minerals, left tools behind, and slowly retreated, leaving the cave largely to silence again. Sound behaves differently underground. Footsteps echo longer than expected. Voices flatten and stretch. In some chambers, silence feels heavy, as if absorbed by the stone itself. Without light, depth loses meaning. Distance becomes impossible to judge. Despite its vastness, Mammoth Cave is fragile. A single touch can damage formations that took centuries to form. Airflow changes can alter humidity. Foot traffic can affect microbial ecosystems adapted to darkness. Preserving the cave requires restraint as much as access. Carefully engineered walkways now guide visitors through selected sections. They protect delicate surfaces while allowing humans to move through a world never designed for us. Beyond these paths, most of the cave remains unexplored, unmapped, and untouched. What makes Mammoth Cave extraordinary is not spectacle. There are no bright colors, no dramatic skylights. Its power comes from accumulation, from the sheer patience of geological time, working invisibly beneath the surface. Mammoth Cave reminds us that some of Earth's greatest wonders do not announce themselves. They do not rise into the sky. They do not demand attention. They exist quietly below, expanding slowly while life continues above, unaware. Here, exploration does not lead upward. It leads inward, into darkness shaped by water, chemistry, and time. Mammoth Cave is proof that the Earth's most expansive landscapes are not always the ones we see. Some of them lie beneath our feet, waiting not to impress, but to endure. In the remote deserts of northern Mexico, a silent congregation stands frozen in stone. Valle de los Monjes, the Valley of the Monks, reveals a landscape shaped not by hands, but by patience. Rising from the desert floor are towering rock columns, some exceeding 30 meters in height. Their forms are narrow, vertical, and uncannily human. From a distance, they resemble hooded figures gathered in ritual, standing motionless beneath the open sky. These formations were not carved quickly. They are the result of millions of years of erosion. Wind stripped away softer sediment. Rare rainfall seeped into fractures. Temperature swings expanded and contracted the rock, weakening it grain by grain. What remained was the hardest stone, left standing while everything around it slowly vanished. Geologically, the valley sits within an ancient desert basin shaped by tectonic uplift. As layers of volcanic tuff and sedimentary rock were exposed, nature began a long process of selective removal. No blueprint, no symmetry by design, only physics deciding what survives. Light transforms the valley throughout the day. At dawn, long shadows stretch across the ground, turning each pillar into a dark silhouette. At midday, harsh sun flattens detail, revealing surface textures etched by sand and time. At dusk, the formations glow in muted reds and browns, their outlines softening as the desert cools. The silence here is complete. There are no rivers, no trees, very little life. Wind moves freely between the columns, amplifying the sense that this place is unfinished, still being shaped, still eroding. Valle de los Monjes is not dramatic in motion. Nothing erupts. Nothing collapses. Its power comes from stillness, from the realization that these structures were built by absence rather than force. Unlike human architecture, there was no intention to impress, no effort to endure. Yet these stone figures have stood longer than most civilizations ever will. Visitors often describe a strange unease, not fear, but awareness. The feeling of being observed by something older than memory, something indifferent to presence. This is geology, performing slow architecture, a reminder that time, given enough patience, can create forms as complex and evocative as any human design. Valle de los Monjes does not tell a story loudly. It whispers it through erosion, through silence, through the long disappearance of everything that once surrounded these stones. Here, the desert is not empty. It is carefully edited. In Western Australia's Nambung National Park, the ground rises into silence. The Pinnacles Desert stretches across pale yellow sand, where thousands of stone pillars stand exposed beneath an open sky. From a distance, they appear arranged, deliberate, as if placed by design. But nothing here was planned. These formations are made of limestone. They began as shells and skeletal fragments on an ancient seabed, deposited millions of years ago, when this region lay beneath shallow ocean water. As the sea retreated, the sediments hardened. What followed was not construction, but removal. Wind became the dominant force. Rain arrived rarely, but precisely. Temperature shifted sharply between day and night. Over tens of thousands of years, softer material was stripped away grain by grain, leaving behind denser limestone cores. What survived became vertical. What weakened disappeared. Some pinnacles rise more than 4 meters high, others barely reach the knee. Many are smooth and rounded, others are sharp, ridged, or hollowed from within. Each shape reflects subtle differences in composition, exposure, and time. No two are identical. Walking among them feels disorienting. There is no clear horizon, no single focal point. The eye moves constantly, trying to impose order on a landscape that resists it. At times, the pillars resemble ancient tools, at others, skeletal remains, or figures paused mid-motion. Light plays a critical role here. At sunrise, long shadows stretch across the sand, exaggerating height and distance. The desert feels crowded. At midday, the sun flattens contrast, revealing texture and erosion patterns etched into the stone. At sunset, the pillars glow gold and amber, their edges softened as the temperature drops. Despite its appearance, the pinnacle's desert is fragile. The limestone continues to erode. Wind still removes sand. Rain still dissolves exposed surfaces. This is not a finished landscape. It is a moment within a longer process. Life persists quietly. Small plants anchor themselves in protected pockets. Insects and reptiles navigate between stones, adapted to heat and scarcity. The ecosystem is minimal but precise. Nothing here is wasted. What makes the pinnacles extraordinary is not scale, it is clarity. The geology is exposed. Nothing is hidden. The process is visible in every edge and cavity. There are no signs explaining where to look. No single formation demands attention. The desert works as a whole, a gallery without walls, a record of time written in subtraction. Unlike landscapes shaped by water or ice, this one was sculpted by patience and absence. No floods, no eruptions, just erosion, repeated endlessly. The Pinnacle's desert reminds us that nature does not always build by adding. Sometimes it creates by removing everything that cannot endure. Here, what remains is not what was strongest, it is what lasted longest. And in that endurance, the desert reveals a quiet truth. Even the most alien landscapes on Earth can be explained, but understanding them requires time, the same kind that created them. In northern Iran, on the edge of the Alborz Mountains, a hillside appears to be flowing, not with water, but with stone. Badabi Surt is a series of natural terraces formed entirely by mineral-rich springs. For thousands of years, water has emerged from the earth here, saturated with calcium carbonate and iron oxide. As the water spills downward, it leaves something behind, layer by layer, drop by drop. What remains is a stepped landscape of hardened stone pools, frozen in motion, creamy whites, deep oranges, and rusted reds spread across the slope, each color marking a different chemical reaction. This is not decoration. It is data, a visible record of chemistry at work. The process is slow, almost imperceptible. As water flows over the surface, carbon dioxide escapes into the air, calcium carbonate crystallizes and solidifies, iron oxidizes. The stone grows outward millimeter by millimeter, year after year. Unlike waterfalls carved by force, Badabi Surt was built by patience. No collapse, no erosion, only accumulation. Each terrace holds water with a slightly different mineral balance. Salinity varies. Temperature shifts subtly. These differences create sharp color boundaries between pools, giving the hillside its unreal appearance. Yet everything follows simple physical laws. The springs themselves are ancient. Fed by groundwater traveling through deep limestone layers, they have remained active for millennia. As long as the water flows, the terraces continue to evolve. If the flow stops, the process ends. Walking across Badabi Surt feels delicate. The stone is solid but fragile. A single footprint can break formations that took centuries to form. This is geology in its most vulnerable state. There are no guardrails here, no engineered paths, only exposed surfaces shaped by chemistry and gravity. The site demands restraint. observation instead of interaction. Light transforms the terraces throughout the day. At sunrise, the pools glow softly, reflecting pale gold. By midday, the colors sharpen, revealing mineral textures and crystalline edges. At sunset, the entire slope deepens into red and amber tones, as if the mountain itself were cooling. Badab-e-Surt does not feel finished. It feels active, alive. Every pool represents a moment in an ongoing reaction that has not yet concluded. What makes this place extraordinary is not how dramatic it looks, but how quietly it formed. No violence, no speed, just water obeying chemistry and time allowing the results to remain. Badab-e-Surt reminds us that some of Earth's most unreal landscapes are not shaped by extremes. They are shaped by consistency, by repetition, by patience stretched across centuries. Here, nature does not rush, and in that slowness, it creates something that feels impossible, yet entirely real. On Iceland's Reykjanes Peninsula, where volcanic rock still holds the memory of fire, a pool of milky blue water appears against a field of black lava. The blue lagoon looks artificial at first glance. Too smooth, too bright, too unreal to belong to the Earth. But this landscape is entirely the result of geology. The lagoon sits within one of the most active volcanic zones on the planet. Beneath the surface, magma heats groundwater nearly 2,000 meters below ground. That superheated water rises through fractured basalt, carrying dissolved minerals with it. When it reaches the surface, it cools, and something unexpected happens. Silica particles precipitate out of the water, suspended, microscopic, and light reflective. They scatter sunlight in a way that produces the lagoon's distinctive blue-white color. Not paint, not dye, physics. The water remains naturally warm year-round, averaging between 38 and 40 degrees Celsius. Even as Arctic winds sweep across the lava fields, steam rises constantly from the surface. The contrast is immediate. Heat against cold, blue against black, movement against stillness. Although the lagoon formed near a geothermal power plant, it is not industrial runoff in the conventional sense. The water is a byproduct of clean geothermal energy production, filtered through layers of volcanic rock. What began as excess flow became a stable system, sustained by the same forces that shaped Iceland itself. Basalt surrounds the lagoon on all sides, porous, dark, jagged. This rock absorbs heat during the day and releases it slowly, helping stabilize the water temperature. The ground beneath remains warm, even in winter. Chemically, the lagoon is hostile to most life. High silica content prevents algae growth. The mineral balance limits bacteria. This absence of biology is what keeps the water opaque and luminous. Nothing clouds it. Nothing consumes it. Human bodies respond quickly. Silica coats the skin. Minerals settle into pores. Heat relaxes muscles strained by cold environments. But the experience is secondary to the setting. What makes the Blue Lagoon extraordinary is not comfort, it is context. You float in warm, glowing water while standing on the cooled remains of ancient lava flows. Steam rises into freezing air. The earth beneath you is still alive, still shifting, still generating energy. Light changes everything. Under cloud cover, the lagoon turns pale and diffuse. Under direct sun, it intensifies, almost electric. At night, reflections soften, and the water absorbs surrounding darkness. Despite its popularity, the lagoon remains a geological event. It exists only because volcanic heat, water chemistry, and rock permeability align perfectly here. Change any one factor, and the lagoon disappears. This is not a permanent feature, it is a moment, a balance point. The Blue Lagoon reminds us that some of the world's most surreal places are not carved by erosion or time alone. They are created by active systems still in motion. Here, geology does not belong to the past. It is happening now, quietly, continuously. The lagoon does not imitate another world. It reveals one that already exists beneath our feet, warm, unstable, and constantly transforming. In the Danakil Depression of Ethiopia, the land drops below sea level and refuses comfort. Here lies Lake Karum, also known as Lake Assal, one of the lowest places on Earth and one of the most extreme. The lake sits more than 100 meters below sea level, in a region shaped by tectonic tension. Africa is slowly tearing itself apart here. The Earth's crust thins, heat rises, water evaporates faster than it can return. Lake Karum is fed not by rivers, but by underground brines rich in sodium chloride. As water reaches the surface, the desert takes control. Temperatures routinely exceed 40 degrees Celsius. Sunlight is relentless. Evaporation accelerates. What remains is salt, crystallized, blindingly white, spread across the surface in sharp geometric patterns that shift and fracture with heat. The lake's salinity is so extreme that the human body floats effortlessly. Density replaces buoyancy. Physics takes over. This is not a blue lake. It is pale, opaque, reflective. Light bounces off the salt crust with such intensity that the horizon seems to dissolve. Depth becomes difficult to judge. Distance loses meaning. Geologically, Lake Karum exists at the intersection of volcanism and evaporation. Magma lies close to the surface beneath the basin. Sulfur vents dot the surrounding landscape. Occasional tremors remind visitors that the ground here is unstable, still forming, still breaking. Life survives, but only selectively. Microorganisms adapted to hypersaline conditions inhabit the brine. Few others can endure. Vegetation is almost absent. Shade does not exist. Yet humans have lived with this landscape for centuries. The Afar people harvest salt here by hand. They cut rectangular slabs directly from the lake's crust using simple tools. Each block is lifted, stacked, and carried across the desert by camel caravans. This process has changed little over time. No machines, no shortcuts, only endurance. Salt was once currency here, a commodity traded across East Africa. Even now, the practice continues, not because it is efficient, but because it is possible, because knowledge persists where technology would fail. Working conditions are brutal. Heat reflects upward from the salt, amplifying exposure. There is no fresh water nearby, no shelter. Only routine and experience prevent collapse. What makes Lake Karoo extraordinary is not danger alone, it is clarity. The forces shaping this place are visible: evaporation, heat, tectonic movement, chemistry. Nothing is hidden, nothing is softened. This is Earth without moderation, a system pushed close to its limits, yet still operating. Standing at the lake's edge, the silence is absolute. No waves, no birds, no wind relief, just heat pressing down and light reflecting back. Lake Karoo does not feel hostile by intention. It feels indifferent, unconcerned with presence. And that is its power. It reminds us that some environments are not meant to be conquered or reshaped. They are meant to be understood, respected, entered briefly. In a world where water often symbolizes life, Lake Karoo offers a different lesson. Here, water becomes stone, movement becomes stillness, and survival depends not on control, but on adaptation. Lake Karoo stands as one of Earth's rawest expressions, a place where geology strips reality down to its essentials. Salt, heat, time. Nothing more is needed. High above a deep mountain valley in China, a hand reaches out from solid rock, not in motion, not in blessing, but frozen in stone and steel. Buddha's hand bridge does not look like conventional infrastructure. There are no straight lines, no familiar symmetry. From a distance, it appears sculptural, symbolic, almost mythical. The bridge emerges directly from a sheer cliff face, anchored into layers of limestone and sandstone formed more than 100 million years ago. This is not ground chosen for convenience. It is ground chosen for necessity. There was no flat terrain to build upon, only vertical rock. Engineers drilled deep steel pylons into the mountain itself, securing the structure against gravity, wind, and seismic movement common to the region. Each anchor had to be placed with extreme precision. Any miscalculation would shift stress into the cliff. Failure here would not be gradual. It would be instant. The bridge takes the form of a colossal open palm. 5 fingers extend outward over open air, creating a span of nearly 50 meters suspended above the void. Beneath the sculpted concrete exterior lies a reinforced steel framework designed to distribute weight evenly across the cliff anchors. Construction took place at an elevation of over 1,000 meters above sea level. Workers relied on cables, temporary platforms, and sheer focus. Equipment was often lowered from above. There was no room for heavy machinery. Every component had to be carried, assembled, and secured in stages. Wind speeds here can exceed 100 kilometers per hour. Temperature shifts are sudden. Fog can erase visibility in minutes. The bridge was engineered not only to stand still, but to flex slightly, absorbing movement rather than resisting it. Despite its technical complexity, the structure feels calm, deliberate. Visitors step onto the palm and immediately feel the mountain beneath their feet. The rock does not disappear. It vibrates subtly, a reminder that this bridge does not float above nature. It is attached to it. Glass panels line portions of the walkway, allowing visitors to look straight down into the valley below. Depth becomes unavoidable. The sense of exposure is immediate. There are no distractions, No barriers between body and space. From above, the bridge resembles a sacred symbol carved directly into the earth. From below, it appears almost impossible, a human gesture extended into empty air. What makes Buddha's hand bridge extraordinary is not scale alone, it is intention. The structure does not attempt to dominate the landscape, it mirrors it. The hand emerges from the mountain as if it were always meant to be there. This is architecture shaped by constraint, by geology, by symbolism. Engineering did not overwrite the terrain. It negotiated with it. The bridge serves no essential transportation function. It does not shorten travel. It does not connect cities. Its purpose is experiential. It exists to place the human body in direct conversation with space, with height, with stone. Standing at the edge of the palm, the valley stretches outward in silence. Wind moves freely. Clouds drift below eye level. The mountain remains unmoved. Buddha's hand bridge is not a shortcut. It is a pause, a reminder that some structures are built not to take us somewhere else, but to make us fully aware of where we already are. Here, engineering becomes gesture, and the landscape responds by allowing it briefly. High in the Italian Alps, where mountain valleys once held quiet villages, a stone tower rises from still water. Lago di Resia does not announce itself as a wonder. It simply exists, silent, unsettling. The lake sits at an elevation of nearly 1,500 meters, fed by glacial melt from surrounding peaks. Cold, clear, controlled. But what defines this place is not the water. It is what lies beneath it. In 1950, a hydroelectric project reshaped the valley. 3 natural lakes were merged into one reservoir. To store water, the valley was flooded. Homes vanished, fields disappeared. An entire village named Curon was erased from the surface. Only one structure was left behind, a 14th century bell tower, stone, Romanesque, too solid, to dismantle easily, too symbolic to remove quietly. Today, the tower stands alone in the middle of the lake, its base submerged, its clock frozen. It does not ring, it does not signal time, it marks loss. From a distance, the scene feels surreal. The water is calm. The mountains are unchanged. Nothing suggests disruption. Yet the tower breaks that illusion. A vertical reminder that modern infrastructure always leaves a trace. In winter, the lake freezes solid. Snow settles across the surface. Visitors walk across the ice to reach the tower on foot. The silence becomes complete. No waves, no wind through reeds, only footsteps echoing over what was once a town. Geologically, the valley remains stable. The water behaves predictably. The dam performs its function. Electricity flows to distant cities. By every technical measure, the project succeeded. But Lago di Resia is not a celebration of engineering. It is a record. The tower does not resist the water, it endures it, season after season, freeze after thaw. It absorbs history without explanation. Light transforms the scene throughout the day. Morning mist softens the edges. Midday sun sharpens the contrast between stone and water. At dusk, the tower becomes a silhouette, no longer architecture, but memory. There are no plaques underwater, no visible foundations. The past is not accessible, only implied. What makes Lago di Resia extraordinary is not beauty alone, it is restraint. The landscape does not dramatize what happened here. It holds it quietly. This is a place where progress and absence occupy the same frame, where clean energy and cultural loss coexist without resolution. The lake does not ask to be judged. The tower does not accuse. They simply remain. Lago di Resia reminds us that some of the most powerful landscapes are not shaped by time alone. They are shaped by decisions. And once made, the land remembers them forever. In eastern China, where rivers spread and slow before continuing their course, Luyang Lake Wetland Park exists as a system rather than a scene. At first glance, it feels calm, flat water, ordered trees, open sky, but nothing here is static. This wetland occupies a low-lying floodplain, a place designed by geography to receive excess water. During seasonal rains, water levels rise by several feet. During dry periods, they fall just as dramatically. The landscape expands and contracts in response. Instead of resisting these changes, the wetland absorbs them. Luyang Lake functions like a natural sponge. Rainwater spreads outward across shallow basins. Flow slows. Sediment settles. Pollutants are filtered naturally by soil, plants, and microorganisms. Only after this process does water re-enter surrounding rivers. The trees here are not randomly placed. They grow in long, deliberate rows. Their roots are adapted to survive months of partial submersion. Specialized tissues transport oxygen from air to root tips buried in waterlogged soil. What looks decorative is biological engineering. Life responds quickly to fluctuation. Fish migrate into flooded areas to breed. Birds arrive as water levels peak. Insects emerge in dense cycles, feeding amphibians and reptiles. When the water retreats, the system resets. Nothing remains permanent except adaptation. Human access is carefully controlled. Elevated wooden boardwalks cross the wetland without touching the soil. They float above fragile ground, allowing people to observe without compressing roots or disturbing sediment layers. Small boats move through narrow channels, following routes shaped by water flow rather than imposed geometry. This balance is intentional. Luyang Lake is not a preserved wilderness. It is a designed wetland, an interface between urban development and natural hydrology. Cities nearby rely on it for flood mitigation. Without this wetland, excess water would move faster, higher, and more destructively downstream. Here, danger is slowed. Energy is dispersed. Impact is reduced. The wetland also moderates temperature. Evaporation cools surrounding air. Vegetation absorbs heat during the day and releases it slowly at night. Microclimates form across the park, supporting species that could not survive in fully urban conditions. Nothing here demands attention. There are no dramatic peaks, no sudden drops. The wonder lies in consistency. Water rises. The system responds. Water falls. The system adjusts. Over time, stability emerges from motion. Luyang Lake challenges the idea that control means rigidity. Here, resilience comes from flexibility, from allowing water to move where it needs to go, from designing space that accepts change rather than resisting it. Visitors often describe the park as peaceful, but peace here is not the absence of activity. It is the presence of balance. Beneath the surface, roots breathe, microbes filter, sediment shifts, life adapts continuously. Luyang Lake Wetland Park is not a destination built to impress. It is infrastructure disguised as ecology, a reminder that some of the most effective engineering solutions do not rise above the landscape. They sink into it, quietly, and work. In a century defined by floods, rising water, and climate uncertainty, places like Luyang Lake point toward a different future, one where protection does not come from walls or barriers, but from systems that move with nature instead of against it. Here, the land does not fight water, it listens. High in the western Himalayas of India, a valley exists that appears only briefly each year. For most of the time, it is quiet, green, almost empty. Then, without warning, it transforms. The Valley of Flowers lies at elevations between 10,500 and 14,000 feet above sea level. Carved by ancient glaciers, the valley was shaped long before humans ever saw it. Steep slopes funnel snowmelt downward. Mineral-rich streams spread moisture across the basin. The terrain traps sunlight while shielding delicate life from the strongest Himalayan winds. For most of the year, the valley remains dormant, cold, harsh, unforgiving. Plants survive underground, waiting, then summer arrives. Between June and September, a narrow window opens. Temperatures rise by only a few degrees. Daylight lengthens. snow retreats, and more than 600 species of flowering plants erupt across the valley floor. Blue poppies, Cobra lilius, primulas. Each species follows its own internal clock, blooming in carefully timed waves rather than all at once. Color moves across the landscape like a signal, advancing and retreating as conditions shift. This precision is not accidental. At this altitude, plants have only weeks to complete their life cycles. Roots store energy underground for months. Stems grow rapidly. Flowers bloom, are pollinated, and release seeds before cold returns. Insects respond immediately. High-altitude bees and butterflies migrate upward, drawn by color and nectar. Pollination happens fast, efficiently. There is no margin for delay. The valley itself creates a microclimate. Its bowl-shaped terrain holds moisture. Clouds gather and release rain gently rather than violently. Soil remains thin but fertile, replenished by glacial minerals year after year. From a distance, the landscape feels unreal. Color blanket slopes that were bare weeks earlier. Patterns appear chaotic, yet follow strict biological rules. Nothing blooms randomly. Nothing blooms alone. Then, just as suddenly, the process ends. Temperatures drop, storms return, flowers wither, seeds fall. The valley fades back into green silence, leaving little trace of what occurred. For most of the year, it is impossible to imagine what the valley becomes. And for those who arrive too early or too late, it remains invisible. What makes the Valley of Flowers extraordinary is not abundance alone, it is timing. This ecosystem does not exist continuously. It appears, performs, and disappears. There is no guarantee of repetition. A single shift in climate patterns could shorten the window, delay the bloom, disrupt pollination. Here, beauty is not permanent. it is conditional. The Valley of Flowers reminds us that some of Earth's most remarkable landscapes are not defined by scale or force. They are defined by synchronization, by life responding perfectly to narrow margins of opportunity. To stand in this valley during bloom is to witness nature operating at its most precise. Not loud, not dramatic, just exact. And when the season passes, the valley offers no explanation, only silence. A reminder that some wonders do not wait to be discovered. They arrive on their own terms. In northern Chile, deep within the Atacama Desert, the land begins to resemble something unfamiliar. Not Earth as we expect it, but something older, stripped, exposed. Valle de la Luna, the Valley of the Moon, lies within one of the driest regions on the planet. Annual rainfall here is often less than 1 millimeter. Water does not shape this landscape. Wind does. Time does. The valley is composed primarily of iron-rich sandstone and evaporite deposits. Over millions of years, tectonic uplift pushed these layers toward the surface. Once exposed, erosion began its work. Slow, relentless, precisi. Powerful desert winds sculpt sharp ridges and knife-edge crests. Daily temperature swings fracture rock from the inside out. Expansion by day, contraction by night. Grain by grain, stone gives way. The result is a landscape of jagged spines, rippled dunes, and steep slopes that appear carved rather than eroded. Nothing here feels rounded. Nothing softened. Edges remain sharp, as if freshly cut. Color plays a critical role. Rust, red, burnt orange, muted gold. These tones come from oxidized iron embedded in the rock. As light shifts, the valley changes character entirely. At sunrise, shadows exaggerate every contour. Ridges appear taller, depth deepens. The ground feels unstable, as if it might move. At midday, the sun flattens perspective, exposing raw texture and sediment layers laid down long before human history. At dusk, the valley glows not brightly, but quietly, like embers cooling after a fire. Vegetation is almost absent. The soil cannot hold moisture. Roots find nothing to anchor to. Life here survives only at the margins. Sound behaves strangely. Wind funnels through narrow channels. Footsteps crunch sharply against salt crusts. Silence returns instantly when movement stops. The sky above Valle de la Luna is nearly perfect. Clouds are rare. Humidity is minimal. At night, stars appear unnaturally sharp, reinforcing the illusion that this place does not belong to Earth at all. This is why the valley is often compared to Mars, not because it imitates the planet, but because both are shaped by the same absence: little water, extreme exposure, unfiltered time. Scientists study the Atacama to understand planetary surfaces beyond Earth. Its soil chemistry, radiation levels, and dryness mirror conditions found on Mars more closely than almost anywhere else on our planet. Rovers are tested here, instruments calibrated, hypotheses grounded. Yet, Valle de la Luna is not a laboratory, it is a record. Every ridge reveals layers of geological history left uncovered. There is nowhere for erosion to hide its work. Nothing grows fast enough to cover it. Nothing flows long enough to erase it. What makes this place extraordinary is restraint. Nature did not build upward here. It removed everything unnecessary. No trees, no rivers, no softness, only form. Standing in the valley, perspective shifts. Scale becomes difficult to judge. Distance deceives the eye. Features that appear close remain far away. The land offers no shelter, no invitation, only presence. Valle de la Luna does not demand attention. It does not overwhelm with size or color. It unsettles through clarity. This is Earth without disguise, without moderation, without apology. A place where geology speaks plainly, and where time leaves nothing hidden. Here, imagination is unnecessary. Reality is already alien enough. High on the Bolivian Altiplano, near the border with Chile, a lake burns red beneath an open sky. Laguna Colorada does not shimmer softly, it glows. Sitting at an elevation of more than 4,300 meters above sea level, this shallow saline lake exists in one of the harshest environments on Earth. The air is thin, the wind is constant, solar radiation is intense. Nothing here is gentle. The lake's striking red surface is not caused by minerals alone. It is alive. Microscopic algae, rich in carotenoid pigments, thrive in the mineral-heavy water. These pigments, combined with iron-rich sediments eroded from surrounding volcanic rock, give the lake its deep crimson tones. The color is not fixed. It shifts. During colder periods, the lake darkens toward deep red. As temperatures rise and evaporation increases, it fades into rusty orange. Chemistry responds instantly to climate. Laguna Colorada lies within an active volcanic zone. Sulfur springs bubble along the shoreline. Borax deposits crystallize into white islands that float just above the waterline. These pale shapes cut sharply through the red surface, creating stark contrasts that feel almost unreal. Despite the extreme conditions, life persists. Thousands of Andean flamingos gather here, feeding on the same algae that color the lake. Their pale pink feathers echo the water beneath them, creating a rare visual symmetry between biology and chemistry. These birds are highly specialized. Their beaks filter microscopic food from brine that would kill most organisms. Their bodies are adapted to altitude, cold nights, and relentless wind. They arrive, feed, breed, and leave in careful cycles timed to seasonal change. The lake itself is shallow. In many places, it reaches only knee depth, but the surface is deceptive. Soft sediments lie beneath. Crusts crack under pressure. Movement must be cautious. Sound carries far here. Wind hums across the plain. Footsteps crunch on salt and mineral crust. Flamingos move quietly, their reflections breaking the surface with each step. Surrounding mountains frame the basin like a natural amphitheater. Snow-dusted volcanoes rise in the distance, their symmetry contrasting with the chaotic texture of the lake below. Steam occasionally lifts from vents along the shore, reminding visitors that heat still moves beneath the crust. Laguna Colorada is not a place of abundance. There are no trees, no flowing rivers, no shelter. Yet it is not empty. Every element here is doing work. Algae convert sunlight into pigment. Minerals settle and crystallize. Birds extract life from chemical extremes. The system holds together through balance, not comfort. What makes Laguna Colorada extraordinary is not its color alone. It is the clarity of cause and effect. Remove the algae and the red disappears. Change the mineral balance and the ecosystem collapses. Alter the climate window and the flamingos vanish. Nothing here is decorative. Everything is functional. Standing at the edge of the lake, the red surface stretches toward the horizon. The sky feels closer. The land feels exposed. This is not a landscape shaped for visitors. It is shaped for survival at the edge of possibility. Laguna Colorada reminds us that life does not require gentle conditions. It requires precision. Here, biology and geology do not compete. They cooperate. And in that cooperation, one of Earth's most unreal places continues to exist, quietly glowing high above the world below. In different corners of the world, separated by continents and cultures, water collects where fire once ruled. Volcanic crater lakes in Costa Rica and Saudi Arabia reveal landscapes still governed by heat, pressure, and chemistry. These are not lakes formed for permanence. They exist on borrowed time. In Costa Rica, crater lakes sit inside active stratovolcanoes, high above the surrounding forest. Their colors are striking: turquoise, green, sometimes an opaque, milky blue. But these hues are warnings, not invitations. The water here is saturated with dissolved sulfur, iron, and other volcanic minerals. Geothermal heat rises constantly from below. Temperatures can approach boiling. Acidity rivals that of battery acid. Nothing lives in these waters. Gas vents release sulfur dioxide into the air, reshaping the crater floor year after year. Shorelines collapse. New vents open. The lake's color can change overnight as chemical balances shift. This is not erosion. It is active transformation. In Saudi Arabia, the Al-Waba crater presents a different expression of volcanic power. From above, it appears almost perfectly circular, 2 kilometers wide, nearly 250 meters deep, a scar left by a phreato-magmatic explosion roughly 1,000 years ago. At its base lies a flat white floor coated in sodium phosphate and salt crystals. Rainwater gathers briefly, then evaporates under extreme desert heat. Summer temperatures exceed 49 degrees Celsius. Evaporation sharpens mineral patterns into geometric fractures that glow under sunlight. The crater walls expose layered basalt and volcanic ash, revealing the violent sequence that formed them. Each stratum marks a moment of eruption, a pause, then release again. Despite their differences, these crater lakes share a common truth. They are unstable. They respond instantly to changes underground. A slight increase in geothermal pressure can raise water temperature, a shift in gas release can alter color, an earthquake can drain or refill the basin entirely. Nothing here is fixed. Standing at the rim, scale becomes difficult to process. The lake below appears calm, still, but every surface hides motion. There are no trails leading into comfort, no gradual transitions. The environment does not adapt to visitors. Visitors must adapt to it. These lakes are studied carefully. Sensors monitor temperature, gas levels, water chemistry. Scientists watch for signs of escalation, because escalation here means eruption. What makes volcanic crater lakes extraordinary is not beauty, it is immediacy. These places exist at the boundary between solid ground and molten rock, between water and gas, between stability and collapse. They are reminders that the earth beneath us is not finished, not settled, not quiet. Volcanoes do not belong to the past. They are present, active, breathing, and where they briefly allow water to rest, the result is a lake that feels unreal, not because it is rare, but because it is temporary. These crater lakes are not destinations meant to last. They are moments, held in place by pressure and released without warning. Here, nature does not decorate the landscape. It exposes its mechanics. Heat rises, water responds. The earth continues its work, silently. Beneath one of Kamchatka's most powerful volcanoes, a hidden world forms where fire and ice occupy the same space. Mutnovsky Ice Cave is not carved by erosion alone. It is shaped by contradiction. Above the cave, a massive glacier stretches across the slopes of Mutnovsky volcano. Below it, geothermal heat rises relentlessly from the Earth's interior. Where these forces meet, ice begins to hollow itself out. The cave forms as volcanic heat melts channels upward through the glacier. Steam vents carve tunnels. Warm air reshapes frozen walls. Water refreezes again and again, layering time into translucent blue arches and chambers. This is not a stable cave. It changes constantly. Each season alters its shape. Each eruption, tremor, or shift in heat rewrites its interior. Inside, the ice glows. Light filters through thick walls, refracting into shades of electric blue, pale turquoise, and deep cobalt. Bands of volcanic ash run through the ice like dark veins, marking past eruptions frozen in place. Every layer tells a story of heat interrupting cold. Despite surface temperatures dropping below -20 degrees Celsius, the cave remains alive. Steam drifts through narrow passages. Water trickles across the floor. The sound of dripping echoes softly, amplified by smooth ice walls. Movement here is cautious. The ground can collapse without warning. Ceilings thin as heat intensifies below. What appears solid may be temporary. Scientists study Mutnovsky Ice Cave to understand how glaciers respond to geothermal activity. It offers a rare glimpse into processes normally hidden beneath ice sheets. Here, climate, volcanism, and glaciology intersect in real time. The cave is also a reminder of fragility. As global temperatures rise, glaciers thin faster than geothermal heat can reshape them. Passages widen, supports weaken. What once endured for decades may now last only a few seasons. From the outside, nothing suggests what lies beneath. Just snow, ice, steam rising faintly into cold air. But inside, the illusion breaks. This is not a frozen world. It is a moving one. Mutnovsky Ice Cave feels less like a destination and more like a process caught mid-motion. Ice is not permanent here. Fire is not destructive alone. Each defines the other. What makes this place extraordinary is not beauty alone, it is proximity. Here, the Earth's inner heat presses directly against frozen water. Creation and collapse happen at the same time. In silence, Mutnovsky Ice Cave reminds us that some of the planet's most unreal landscapes exist only because opposing forces refuse to cancel each other out. Instead, they coexist, briefly, and leave behind something that should not be possible, but is. In some places, the Earth does not hide its energy. It exposes it, openly, continuously. Askja caldera in Iceland and Geyser Lake in Russia's Kamchatka Peninsula are separated by thousands of kilometers. Yet, they are shaped by the same force. Heat rising from deep below the crust, Askja lies in Iceland's remote central highlands, a vast volcanic depression formed by explosive eruptions more than 10,000 years ago. The landscape feels stripped. Dark lava fields stretch outward. Ash plains lie pale and exposed. Wind moves freely across open ground. At the center of the caldera rests Lake Öskjuvatn, one of Iceland's deepest lakes. It plunges more than 200 meters. Its surface appears calm, steel blue, cold, but beneath it lies volcanic history compressed into silence. Nearby sits a smaller crater lake, Viti. Its milky turquoise water is heated by geothermal activity below. Temperatures fluctuate, chemistry shifts, color changes subtly, depending on gas release and mineral concentration. Nothing here is decorative. Every hue reflects chemistry. Every texture reveals eruption, collapse, and renewal. In Kamchatka, Geyser Lake tells a similar story in a different language. Hidden in a subarctic volcanic region, the lake's surface is patterned with perfectly circular rings: blue, white, turquoise. These patterns are not algae or sediment alone. They are created by gas bubbles rising steadily from geothermal springs beneath the lake. As gas escapes, fine clay minerals are lifted and redistributed, forming concentric shapes that shift slowly over time. The water remains warm even in freezing air. Steam lifts gently from the surface. The ground nearby trembles occasionally, reminding visitors that magma is never far away. Both Askja and Geyser Lake exist in unstable balance. A change in pressure can alter temperature. A shift in gas release can transform color overnight. An eruption could drain or refill these lakes entirely. Scientists monitor these systems closely. Sensors track heat flow, gas emission, water chemistry, not for curiosity alone, but for warning. Because these places do not represent the past. They represent the present. Standing at their edges, the illusion of stillness breaks. The water may rest. The land may appear solid, but nothing here is settled. These are landscapes mid-creation. What makes Askja Caldera and Geyser Lake extraordinary is not scale or beauty, it is honesty. The Earth does not pretend to be stable here. It shows its mechanics. Heat rises, rock fractures, water responds. No filters, no calme façade. These places remind us that beneath every continent, motion continues, slowly, relentlessly. The ground we trust is only temporarily solid, and where the planet allows us to see that truth directly, the result feels unreal. Not because it defies nature, but because it reveals it. Beneath the island of Kefalonia in Greece, light enters the earth and refuses to disappear. Melisani Cave is not hidden in darkness. It is illuminated from above. The cave was formed over hundreds of thousands of years as slightly acidic rainwater seeped through limestone, dissolving rock slowly and patiently. What remains is a vast underground chamber, its roof partially collapsed, opening the cave directly to the sky. Through this opening, sunlight pours in, not evenly, not gently, but with precision. At the center of the cave lies a lake, nearly 30 feet deep. Its water is impossibly clear, a blend of fresh water and seawater filtered through underground channels that connect the cave to the Ionian Sea several kilometers away. This mixing creates a rare optical effect. As sunlight strikes the surface, it refracts through the water and reflects off pale limestone below. The result is color: electric blue, turquoise, silver. The cave becomes a natural prism. At midday, when the sun reaches its highest point, the effect intensifies. Light penetrates directly downward, illuminating the entire chamber from within. The water seems to glow rather than reflect. Depth becomes difficult to judge. The lake appears bottomless, even where it is shallow. Sound behaves differently here. Voices soften, oars dip quietly into water. Every movement feels amplified and restrained at the same time. Geologically, Melisani is part of a larger karst system beneath the island. Rainwater travels slowly through fractured limestone, dissolving calcium carbonate and carving tunnels long before reaching the cave. This process continues today. The cave is not finished. The collapsed roof, which now allows light to enter, was once solid. Its failure was not violent. It happened gradually, as erosion weakened structural support until gravity completed the process. Long before modern visitors arrived, the cave held meaning. Archaeological evidence suggests that ancient Greeks considered Melisani sacred. Artifacts discovered inside indicate offerings left for the nymph Melisani, believed to inhabit the water. Myth merged with geology. Light, water, and stone became symbols rather than processes. Today, visitors enter the cave by small rowboats. There are no engines, no vibrations. Movement is slow and deliberate, allowing the water to remain undisturbed. The reflections remain intact. Walls rise steeply from the lake's edge. Stalactites hang overhead, shaped by mineral deposits that formed drop by drop over millennia. Each formation marks time measured in patience rather than speed. Despite its beauty, Melisani is fragile. A slight change in water chemistry could cloud the lake. Increased disturbance could disrupt sediment balance. The light that defines the cave depends on alignment of sun, season, and angle. This is not a spectacle designed to perform constantly. It appears at its best only for a few hours each day. At the wrong time, the cave looks ordinary, muted, quiet. What makes Melisani extraordinary is not scale, it is interaction. Light enters, water responds, stone reveals. Nothing here exists alone. Remove the opening, and the cave returns to darkness. Remove the water, and color disappears. Remove time, and the chamber never forms. Melisani Cave reminds us that some of the most unreal places on Earth are not defined by extremes. They are defined by alignment. When geology, light, and water meet at exactly the right moment, the result feels almost deliberate, as if the Earth briefly chose to reveal one of its quieter secrets, and then asked us to leave it unchanged. Far south of Tokyo, rising from the Philippine Sea, an island exists inside a volcano, and within that volcano, another volcano breathes quietly. Aogashima Island is not shaped like a typical landmass. It is a nested landscape, an island within a caldera within an island. Roughly 200 kilometers from mainland Japan, Aogashima measures just a few kilometers across. Steep cliffs ring its perimeter, formed by massive eruptions thousands of years ago. These walls isolate the island from the open ocean, turning it inward rather than outward. At the center lies a second volcanic cone, smaller, younger, still active. Geologically, Aogashima is the result of repeated destruction, followed by quiet rebuilding. The outer caldera formed after a catastrophic eruption collapsed the original volcano. Later, magma rose again through the center, constructing a new cone inside the scar left behind. This process did not happen once. It happened again and again. The most recent major eruption occurred in the late 18th century. It forced all residents to evacuate. Lava, ash, and gas reshaped the island completely. When people eventually returned, decades later, they did not rebuild the old village. They adapted to the new terrain. Today, a small community lives inside the caldera itself. Homes sit on fertile volcanic soil enriched with minerals. Vegetation thrives in the sheltered basin, protected from harsh ocean winds by the surrounding cliffs. A microclimate forms naturally, warmer, calmer, more stable than the sea beyond. Steam vents dot the interior. Geothermal heat escapes through cracks in the ground. In some areas, natural steam is used for cooking. Food is placed directly above vents, heated by the earth itself. No fuel required. From above, the island looks unreal, a perfect ring of cliffs. Green slopes descending inward, a central cone rising gently from the basin floor. Few places on Earth reveal volcanic structure this clearly. Access to Aogashima is difficult. There is no large harbor. Ferries depend on calm seas. Helicopters are often the only reliable connection. Weather can isolate the island for days, yet people remain. They farm, they fish, they live with constant awareness of the ground beneath them. Sensors monitor seismic activity. Evacuation plans exist, ready but unused. The volcano is quiet for now. What makes Aogashima extraordinary is not danger alone, it is coexistence. This is not a monument to volcanic power abandoned by humans. It is a settlement built inside it, not in defiance, but in acceptance. The land here is unstable by definition, and yet life continues. Standing on the caldera rim, the scale becomes clear. Ocean stretches endlessly beyond the cliffs. Inside, the island feels enclosed, protected, exposed at the same time. Aogashima does not promise permanence. It never has. It exists as a negotiation between geology and survival, between risk and resilience, between fire and home. The island reminds us that some of the most unreal places on Earth are not uninhabited because they are dangerous. They are inhabited because humans learned how to listen. Here, the volcano does not dominate daily life. It shapes it, quietly, constantly, and beneath every step, the Earth waits, not asleep, just patient. High in the upper Mustang region of northern Nepal, entire cities exist where no cities should, carved not into valleys, but into vertical cliffs. The sky caves do not sit on the land. They cling to it. Rising more than 150 feet above the valley floor, these sandstone cliffs are perforated by thousands of man-made openings. Small at first glance, perfectly aligned, stacked in layers like windows into another era. From a distance, they look impossible, too high, too exposed, too deliberate to be accidental. Geologically, the cliffs are composed of soft Himalayan sandstone, formed millions of years ago when this region lay beneath ancient seas. Over time, tectonic uplift raised the land. Erosion exposed vertical faces, What remained was rock that could be shaped slowly by human hands. Archaeologists believe the earliest caves were carved nearly 3,000 years ago. At first, they served as burial chambers, bodies placed inside stone rooms, sealed from animals and weather. Later, the caves evolved. They became meditation cells, monasteries, homes. Entire networks were carved internally, rooms connected by narrow tunnels, vertical shafts linking levels, living spaces stacked one above another, forming a three-dimensional settlement embedded in the cliff itself. Access was never easy. Wooden ladders, ropes, handholds cut into stone. Every entrance required intention. Every ascent demanded effort. This difficulty was not a flaw, it was protection. Upper Mustang sits along ancient trade routes linking Tibet and South Asia. The caves offered refuge from invasion, wind, and extreme cold. At elevations above 3,800 meters, winters are brutal. Inside the rock, temperature remains stable. Stone becomes insulation. Inside many caves, soot stains the ceilings. Fireplaces once burned here. Walls still hold faded Buddhist murals, reds, blues, golds, painted directly onto stone. Meditation chambers face open sky, aligned with light rather than comfort. Some caves contain manuscripts, bones, tools, evidence of daily life at extreme altitude. Others remain empty, their purpose still unknown. Modern exploration is difficult. Many caves can only be reached using ropes and climbing equipment. Drones now reveal entrances never documented before. Each discovery raises more questions than answers. Why were so many caves built? Why at such height? Why here? The answer is not singular. The caves changed function over centuries. They adapted as climate shifted, trade declined, and religious practices evolved. What remained constant was the cliff itself. Standing below the caves, scale becomes disorienting. The valley stretches wide and silent. Wind moves freely. The openings above feel detached from human reach. Yet, people lived there, worked there, prayed there. What makes the sky caves extraordinary is not their age alone, it is their position. These are not shelters carved where stone was convenient. They were carved where stone was difficult, where access demanded commitment, where survival required adaptation. The caves do not dominate the landscape. They disappear into it, blending color, matching texture. From certain angles, they vanish completely. The sky caves remind us that human ingenuity does not always rise upward or spread outward. Sometimes it moves vertically, quietly, patiently. Here, architecture was not imposed on nature. It was negotiated with it. Stone offered shelter, humans offered time, and together they created one of the most improbable inhabited landscapes on Earth, a vertical civilization suspended between sky and ground, still watching the valley below in silence. Hidden deep within Bhutan's eastern Himalayas, Singyedzong rises, where stone, faith, and endurance intersect. This is not a fortress built on open ground. It is carved into the mountain itself. Perched nearly 10,000 feet above sea level, Singyedzong clings to sheer cliffs of metamorphic rock. Reaching it requires days of travel on foot. Dense forests, glacial streams, steep ridgelines. There are no roads, no shortcuts. Geologically, the cliffs were shaped by ancient fault lines and relentless erosion. Cracks and hollows formed naturally as tectonic forces fractured the rock over millions of years. These voids became the foundation for human presence. In the 8th century, the Buddhist master Guru Padmasambhava is believed to have meditated here while spreading Buddhism across the Himalayas. The caves were transformed into sanctuaries, not built outward but refined inward. Whitewashed walls merge seamlessly with stone. Wooden prayer halls are anchored directly into the cliff face. Nothing stands free. Everything is supported by the mountain. Inside, narrow chambers open into meditation rooms blackened by centuries of butter lamp smoke. Prayer flags flutter at entrances exposed to open air. Wind moves freely through the complex, carrying chants and incense outward into the valley. The isolation is absolute. Clouds drift below eye level. Sound dissipates quickly. The outside world feels distant, almost irrelevant. This remoteness is not accidental. Xingyizong was never meant to be accessible. Distance serves as devotion. Effort becomes ritual. Life here is shaped by altitude. Oxygen is thin. Temperatures drop rapidly after sunset. Stone walls provide insulation, stabilizing the interior climate against extreme cold and wind. The architecture does not compete with the landscape, it disappears into it. From a distance, the structures are nearly invisible, their colors matching surrounding rock. What makes Xingyizong extraordinary is not scale or ornamentation, it is restraint. Nothing here exists without purpose. Every chamber is aligned with silence. Every path is deliberate. Every wall respects the mountain's limits. This is not a monument designed to impress. It is a place designed to endure. Standing at the edge of the cliffs, the valley stretches endlessly below. The drop is immediate, unforgiving, yet the sight feels calm. Xingyizong does not resist the mountain, it accepts it. Here, human ambition does not rise above nature, it settles into it. The fortress remains, not because it dominates the landscape, but because it listened to it. In a world where access is often prioritized over meaning, Xingyizong reminds us that some places are powerful precisely because they are difficult to reach. Faith here is not declared loudly, it is practiced quietly, carved into stone, and held in place by the mountain itself. As this journey comes to an end, one truth becomes impossible to ignore. The most unreal places on Earth are not mistakes, they are results. They exist because time was allowed to work, because pressure accumulated, because water moved, because humans adapted instead of retreating. Some of these landscapes were shaped almost entirely by nature. Wind carving stone, heat reshaping ice, minerals staining water with color and chemistry. Others exist because people chose to stay where survival was uncertain. They carved into cliffs, built inside volcanoes, lived beneath mountains that could collapse or erupt at any moment. None of these places were designed to impress. They were shaped by necessity, by patience, by resilience. What makes them feel impossible is not their appearance, it is their honesty. They reveal processes we rarely see. Geology in motion. Ecosystems balanced on narrow margins. Civilizations negotiating with extreme terrain. These places remind us that Earth is not static. It is active, still forming, still changing beneath our feet. They also remind us of our role, not as masters of the planet, but as participants within it. Every structure, every settlement, every path carved into stone carries consequences that last longer than intention. Some become wonders, some become warnings. The world still holds landscapes that challenge certainty, places that resist explanation, places that demand respect rather than control. To explore them is not to conquer distance. It is to understand limits. And perhaps the greatest discovery is this: reality does not need to be exaggerated to be astonishing. If we slow down and truly look, the Earth is already far more extraordinary than we imagine.